All right, so in this video, we're going to go over modeling Bitcoin's value scarcity. And we already talked about how Bitcoin is unforgivable costliness due to the electricity to produce new Bitcoins, can't be easily faked, can't be easily counterfeited, and so on. And Amos's blog, he talks about scarcity in terms of stock-to-flow ratio, explains why gold and Bitcoin are different from consumable commodities like copper, zinc, nickel, brass, and so on, because they have a high stock-to-flow ratio. And scarcity can be quantified by stock to flow. And remember, stock to flow would be 1 over the growth rate in the supply. So the number of blocks per month can be directly queried from Bitcoin blockchain. The actual number of blocks differs quite a bit from the theoretical number because blocks are not produced exactly every 10 minutes. So with the number of blocks per month and known block subsidy, you can calculate the flow and the stock. You could come close if you use the BTC supply model over here. And maybe this would be a better model depending on what you're trying to do. Or maybe if you have the number of blocks, you can plug that in and calculate the supply, and then you can build a different model from that. Or maybe you would want to use this if depending on what kind of forecasting you're doing. But anyway, for now, we're going to stick to what was done in the original paper. So we're just going to copy it. So let's create a new data frame of only the columns that we need. So we need the Bitcoin price and the stock to flow. So let's do BTC. I'm sorry. No, it wasn't number of BTC. It was price. We want price. And we want stock to flow. Notice, so data is our data frame, and I want 2 columns. Whenever you want 2 or more columns out of that data frame, you have to give it in a list. So we're giving it in a list. We'll look at our df, and you see a bunch of nans, a bunch of knotted numbers. So we got to get rid of all of that. So let's do df.drop in A. I'm going to do axis equals 0. So this means it's on the index. Axis equals 0 is the index. Axis equal 1 is the number, or is along the columns. We want to delete anything. So how any will delete any row that has a nan in it. Threshold for this, we don't have to specify all of that, but we do want to, if I just do this, you see that it worked, but it did not keep it in place. We want to keep it in place. So in order to do this, you'll say in place equal true. And for this, you can ignore this for now. So we want to create a model for Bitcoin prices using stock to flow. However, even if there is a relationship, it may not be linear. We don't know if it's linear or not. So we're going to kind of look at 4 different regressions, or 4 different specifications for a regression. So for this, we're going to look at 1 specification. So the first one, we're going to look at Bitcoin price as a function, or as a linear function of stock to flow. This is going to be our first scatter plot, or our first specification. Then we're going to look at Bitcoin with some intercept, some slope, of where the explanatory variable is going to be the log of stock to flow in our error term. We're going to look at Bitcoin. We're going to look at log Bitcoin is equal to some intercept, some slope of stock to flow in our error term. And we're going to look at our final specification of log Bitcoin price is equal to some intercept plus some slope multiplied by the log of stock to flow. In the original paper, this is what they went with. They didn't really go over anything else. They just said that there's a power rule, so they just jumped straight into this, and that's not necessarily true. I mean, it is true for this, and you can see it, but we're going to actually look at the other options, the other specifications of this regression, and we'll see whether or not there could have been other options. So we're going to create a 2x2 subplot of each combination of Bitcoin, log Bitcoin, stock to flow, and log stock to flow, where Bitcoin is the dependent variable, and start to flow is the explanatory variable. So let's create our subplot. So you could do this a couple different ways. You could do it with a for loop. You could do it with a we're just gonna not do the overcomplicated ways, even though they may be more efficient. We're just going to do the we're just going to use a subplot. So we're going to do plt.subplot. For this, we're going to do a 2 by 2, so 2 rows by 2 column by, and then the third number is going to be which one we're working with. So this is going to be the one in the top left. So let's do a scatter. This is going to be df price with respect to df sf. We'll just leave it at this for now. Let's add our y label. So our y label is going to be BTC, and then you know what? Let's just create the scatter plots first. So for the next one, we're going to do subplot 2 rows by 2 columns. So we're doing the same one. Now it's going to be in the top right. So I do this. We're going to see here. It's going to be right over there. This one, let's do df price again. And then for our x value, or our explanatory variable, now let's do the log of the stock to flow. Now we're going to do 2 more subplots. So 2 rows by 2 columns. So we're doing the same one. We're going to do the third. Once this is going to be in the bottom left, it's going to be down here. We'll do plt.scatter. Now let's do the log of Bitcoin, the log of our Bitcoin, of the price of Bitcoin with respect to our stock to flow. And for our final one, this one's going to be in the bottom right. It's going to be a 2 by 2 subplot. We're dealing with the fourth figure. I'm going to do another scatter. This is going to be with respect to or the log Bitcoin price with respect to the log of the stock to flow. So I'll run it. So there's a problem here. Looks like I may have spelled something wrong. I forgot the data frame, so we weren't actually getting the column. So now this is our scatter plot. Now let's clean it up a little bit. Let's make it a little bit bigger. Let's say plt.figure, and let's do figsize is equal to 14 by 8. So now it's a little bit cleaner, a little bit larger. You can see a little bit better. And for this, let's add a Y label over here. Both of these have the same Y label. I did this on purpose. So this is going to be Bitcoin price. So now we run it. We have our Y label, BTC. So both of these deal with Bitcoin price. Now let's add another Y label for the bottom. Let's say Y label is another. This one's going to be log, let's say LN BTC. So both of these had the same Y label. Both of these had the same Y label. Then down here, now let's add our X label. So both of these, the first one and the third one on the left, both have the same X axis. And that is our log stock to flow, or at least it's what it's supposed to be. Maybe not. Well, for this, it's stock to flow. Sorry, stock to flow. This one is plt.xlabel. This is going to be ln stock to flow. And on this, you can see that the log stock to flow with or log Bitcoin price with respect to log stock to flow does have the most linear model. So for part 2, we created the 2 by 2 subplot of each combination, where Bitcoin is the dependent variable and stock to flow is the explanatory variable. And we can show, or just visually, we can show that the logged Bitcoin price with respect to the logged stock to flow is the most linear. And just to show it a little bit more, we'll create a linear plot where X is going to be the log of price. Y is going to be the log of our stock to flow. And our data, let's say df. Say we have an error, do a red plot instead. So now it works. So that one works. I don't know why linear model didn't work. Usually they either one will work. But anyways, so this, you can fit a straight line on it pretty well. So we're going to go in more detail. We're going to actually use stats models to create an ordinary least squares regression. But just by looking at this so far, it does seem that there is a relationship between Bitcoin and stock to flow, or logged Bitcoin and stock to flow. And then the specification of this regression, the specification of the regression that we're going to do is going to be log Bitcoin price. It's going to be equal to then our intercept plus our estimated slope multiplied by log stock to flow at time t plus our error term. And of course, if you're going to use this, this is the model that we're going to use, or we're going to estimate these coefficients. You'd use this to estimate the log Bitcoin, and to calculate Bitcoin, this would be equal to e to the power of all of that. So next video we'll continue with this, and we will actually use stats models to run or to estimate the ordinary least squares regression.